Hello students, hello everybody. Welcome back to my class. This is Pradip sir with another session of Introduction to Trigonometry from class 10 Mathematics. In the previous session, we have learned about the different trigonometric ratios and solved few problems related to it. Today I am going to continue with the same topic and will solve few more problems so that it will become more easy for you to understand and solve any other problem based on this topic. Okay, so let me start with one more question from NCERT Mathematics class 10. The question is, in triangle PQR, right angled at Q, right angled at Q, right angled at Q, PR plus QR equals to 25 centimeter, PQ equals to 5 centimeter, what we have to find? Determine the value of sin P, cos P and tan P. So it is given that sum of these two sides PR and QR is equals to 25 centimeter, PQ is 5 centimeter, and we need to find the value of three trigonometric ratios, that is sin P, cos P and tan P. Okay. So first of all, diagram a right angle triangle. Since we have to find the trigonometric ratios of angle P, so I am taking this angle as P, and it is given in the question that Q is the right angle, so this is Q, naturally this is R. Okay, so first of all, PQ is 5 centimeter and the value of PR plus QR is 25 centimeter. They are not given separately, their sum is given. So I am taking this value PQ as X, therefore PR will be, it will be 25 minus X. Okay, so let QP is QR is equals to X and PR is equals to 25 minus X. Okay, so since this is a right triangle, therefore we have to use the Pythagoras theorem to find the values of other two sides of this right angle triangle. Okay, so using Pythagoras theorem, we have PQ square plus QR square is equals to PR square. Okay, this is Pythagoras theorem. Now let me replace the values. PQ is 5 centimeter, so 5 square. QR is X square and PR is 25 minus X whole square. So this is 25 plus X square and this is in the form A minus B whole square. So it will be A square minus 2AB plus B square. So X square will cancel from both sides. Okay, 25 and this side 25 square is 625 minus this is 2 into 25 is 50x. So let me take 50x to this side. It will become plus 50x and 25x to the right hand side. So it will be 625 minus 25, or we can say 50x is equals to 600. Therefore we can say x is equals to 600 upon 50, that is 12. That means we have got the value of x as 12. Now if x is 12, then what will be PR? It will be 25 minus 12, that is 13. So we have got the values of all the three sides of this right angle triangle PQR. Okay. Now we can easily find the values of sin P, cos P and tan P. So let me erase these first. Now see the diagram. First, sin P. Sin means perpendicular upon hypotenuse. Perpendicular upon hypotenuse. That is QR upon PR. That is 12 upon 13. Then cos P. Cos P means base upon hypotenuse. So PQ upon PR. That is 5 upon 13. And tan P. Tan P means perpendicular upon base. That is QR upon PQ. So it is 12 upon 5. I hope we have understood how to find the trigonometric ratios. Okay, just go through the whole solution, the steps. So this is another question. If sin theta, theta is the angle of the triangle. If sin theta is equals to a square minus b squared upon a square plus b square, then find the values of all other trigonometric ratios of theta. So here angle theta is the acute angle whose all trigonometric ratios we have to find. So first of all, a triangle, and this is theta. Let me name the triangle as ABC, where angle B is the right angle. Okay, and the acute angle on the base is theta. So first of all, it is given in the question that sin theta is equals to a square minus b square upon a square plus b square. So as we all know, sin theta means it is perpendicular upon the hypotenuse. So perpendicular here is AB and hypotenuse is AC. So AB upon AC is equals to a square minus b square by a square plus b square. So since there is no numerical values given in the ratio, then we can take AB as a square minus b square and AC as a square plus b square. Okay, now using Pythagoras theorem, I have to find the value of the third side BC, then I can proceed further. So AB square plus BC square is equals to AC square. This is Pythagoras theorem for right angle triangle. Now AB square means is a square minus b square whole square. BC square is not known, so let it be like that. AC square is a square plus b square whole square. So it is in the form of a minus b whole square and it is in the form of a plus b whole square. So let me simplify the whole thing. So a square minus a minus b whole square is a square minus 2ab plus b square. So a square means the square of a square. So it will become a to the power 4 minus 2ab. So 2a square b square plus b square means square of b square, that is b to the power 4 plus bc square will remain as it is. This side it is a plus b whole square form or x plus y whole square form. So x square means a square of a square, so it will be a to the power 4 plus 2xy means 2 into a square b square plus y square means square of b square, that is b to the power 4. Now from both sides I can cancel this a to the power 4 and b to the power 4. Okay. So what will happen? This 2a square b square will go to the right hand side. So bc square, this bc square equals to 2a square b square plus 2a square b square. So we can write bc square is equals to 4a square b square, or we can say that bc is equals to 2ab. Root over of 4a square b square is 2ab. Okay. Now I cannot take the negative value because side of the triangle cannot be negative. That's why I have taken only the positive value 2ab. Okay. So I have got the value of BC as 2ab. Got it? Okay. Now I have got all the length of all the three sides values. So I can easily find the value of all the trigonometric ratios of the acute angle theta. So let me first erase this. Sin theta is already there, cos theta, so cos theta is based upon hypotenuse, that is 2ab upon a square plus b square. Tan theta is perpendicular upon base, that is a square minus b square upon 2ab. Now the reciprocal of sin theta is cosec theta. Cosec theta will be a square plus b square divided by a square minus b square. Sec theta is the reciprocal of cos theta, so it will be a square plus b square upon 2ab. And cot theta is the reciprocal of tan theta, so cot theta will be 2ab upon a square minus b square. Okay, so hope we have understood how to find all these ratios. Just go through the process. The sum was really very easy, only little bit calculation part during the Pythagoras theorem. Otherwise the whole thing is very simple. Okay, so let me solve one more problem. The next question: if angle A and angle B are acute angles such that cos A equals to cos B, then show that angle A is equals to angle B. Means here cos A and cos B are equal, the values of cos A and cos B are equal. So we need to show that angle A and angle B are also equal. Okay, so first of all let me draw a triangle where the acute angles are A and B, and the triangle is ABC. The acute angles are angle A and angle B, and angle C is the right angle, as it is mentioned that A and B are acute angles. Okay, so that's why I have taken angle C as the right angle. Now let me draw one more triangle. In the previous diagram, acute angle B is the angle on the base, and here I am going to take angle A as the base angle. Now why I have drawn two diagrams? The reason is already known to you, but still once again I am telling you. Cos A and cos B, since here the acute angle is cos A, so I have drawn this diagram for that one, for cos A. And cos B, I have drawn angle B at the base. So because to avoid confusion, that when I am taking angle A as the acute angle on the base, then AC will become the base and BC will be the perpendicular. But when I am taking cos B, means I am taking the acute angle at the base, then BC will become the base and AC will be perpendicular. Now if you want to draw only one diagram and solve the problem, then there is no issue. You can do it. And there is no hard and fast rule that we have to draw two diagrams. I am only drawing two diagrams to avoid silly mistakes. Okay, it is general thing found in many students that they used to take base for cos B, and this is the perpendicular, and again for cos A also they consider BC as the base and AC as the perpendicular by mistake. So whenever we are drawing two diagrams, the chances of making this silly mistake will be reduced. Okay, let us now come back to the point. It is given in the question that cos A equals to cos B. Now what is cos A? So let me consider this diagram. Cos A means base upon hypotenuse. It is given that cos A equals to cos B. So cos A means base upon hypotenuse. Hypotenuse is AB. And what is cos B? Cos B is also base upon hypotenuse. That is, this is the base and this is the hypotenuse. So BC upon AB. Now if we cancel AB from both sides, because AB is the side of a triangle and it cannot be 0, so we can easily cancel AB from both sides. Then what we are getting? We are getting AC is equals to BC. Okay, that means in a triangle two sides AC and BC are equal. So suppose this triangle AC and BC are equal. Now we have learned a theorem in class 9 that if two sides of a triangle are equal, then their opposite angles are also equal. That was the theorem. So here from that theorem we can write, if AC is equal, then angle opposite to AC is B. So angle B. And BC, so angle opposite to BC is angle A. So here we must mention why we are writing. We have to mention the reason. That is, angle opposite to equal sides of a triangle are equal. Angles opposite to equal sides of a triangle are equal, which implies angle A is equals to angle B, and that is what we have to prove. So it is proved. Understood? So that's all for today. We have solved 3 problems. In the next session I will start a new topic from this chapter, that is standard angle, the trigonometric ratios of some standard angles like 0 degree, 30 degree, 45, 60 degrees and 90 degrees. So till then you have to practice all these type of sums again, find some more sums in other books, sample papers, examination papers, and try to solve those problems. Hope you will be able to solve all this problem. I have full confidence on you. So let us meet in the next class. Till then, goodbye and have a nice day.